Okay, so this is an introduction video really to trigonometry, which is a really exciting topic in mathematics, and for a lot of you guys it will be the first time that you've done trigonometry. Well, it probably will be because grade 5 is where we introduce it. Okay, so I'll be doing like an introduction video in this video, but also looking at finding missing sides in right angle triangles. So let's get into it. Right, we use trigonometry at the grade 5 level to find missing sides and angles, and really importantly in right angle triangles. So for example, right, two triangles here where you're given some information, but they're both right angled, and you could be finding a missing side, like in this one over here, or you could be finding a missing angle, like this one over here. Okay, but they've got to be right angle triangles for what we're looking at today. And then there's three really important trig ratios that we need to know, right, which are these ones here, which are sine, and this symbol here is called theta, so that is called theta, which just means, right, it's a Greek word that means angle. Okay, so for example, theta in this first triangle would be 36. And then we've got all these kind of abbreviations, right? O divided by h. What does that really mean? Well, we've got three sides, which you'll see in a second, which are the opposite side, hypotenuse, and adjacent in triangles, which will all make sense in a second. But just to really quickly, show you, there are three formulas or three trig ratios that we will be using. Sine theta is over h, cos theta over h, and tan theta is over a, but it'll be much clearer in a second. Okay, first of all, right, labeling triangles is absolutely key, really, in any trigonometry problem, right? And we'll see what these O, H, and A really stand for. Now, so here we've got a right angle triangle, and there are three sides in any right angle triangle, which are the opposite side, the hypotenuse, and the adjacent. So in my triangle here, you always label your triangle with regards to the angle theta, this thing here. Okay. Right, the first side, the opposite side, which we denote as O, okay, in short, the opposite side is always opposite the angle. So the opposite side would be this side here. And I'm not going to write opposite, I'm just going to write O. It just makes things a lot clearer and quicker. So my opposite side is always opposite the angle. Like, imagine the angle is like an eye, and it looks at the opposite side. Okay, that is O. The hypotenuse, right, is the longest side. Sorry, let's go and call it H. Hypotenuse is your longest side, which is always opposite the right angle. So H goes in there. Okay, so hypotenuse here is your longest side in the triangle, right? And that's quite clearly to see in this one. We can see this one here is the longest side, but often triangles are rotated, so you've got to be able to spot that the hypotenuse is opposite the right angle. That's really important. And the side left over we call the adjacent side, which is capital A, and A is basically your leftover side. Adjacent means next to both of your angles, so the angle theta and the right angle. But the way that I label my triangle, I always go opposite, hypotenuse, adjacent. A is always the one left over, basically. So opposite is where this O comes from, hypotenuse is where this H comes from, and adjacent is where this A comes from. Okay, they are the three sides in our right angle triangle. So similarly down here, right, if we're given this triangle here, you can try and label this triangle yourself. We'll go through it now. But here's my angle, theta, this side opposite the angle I call my opposite side, O, opposite. The hypotenuse, more tricky to spot here, right, is my longest side, which is this one here. It is opposite, right, the right angle. So that must be H, and the adjacent side is the one left over, next to the two angles. Okay, so adjacent means next to the two angles. So this first step in any trigonometry problem is being able to label your triangle properly. If that goes wrong, everything becomes a bit of a nightmare. So this is a really key step in trigonometry. So once you've labelled up your triangle, you need to use one of the three trig ratios to find a missing side or angle. And we've seen already, we've got this thing here, sine theta is over h, cos theta is a over h, and tan theta is over a. And I like to use the trig triangles because I think they're really useful, particularly when you first start with trig, to find missing sides and angles. So this triangle here is just put this formula, okay, into the triangle, right? So we're saying that sine of the angle, this one here, is equal to O divided by H. So the way that these triangles work, if you want to go and find sine of the angle theta, what that will mean will be more clear later on as we look at the example, but you would put your finger, so I'd cover it up here, you put your finger over it, okay, and you can literally see we've got the opposite side divided by H, which we can see here. If you wanted to find the hypotenuse, so if you wanted to go and find H, you'd put your finger over it, like this one here, and it's going to be O divided by sine of the angle theta. So that would be equal to O over sine of the angle. if you wanted to go and find the opposite side, you put your finger over it and you would say that O is equal to sine of the angle times by hypotenuse. So sine of the angle times by hypotenuse. So that's just how we use equation triangles. They're really useful. Okay, so I would, well, you need to remember these triangles. Okay, and there's a really useful way that we can remember these, which is called SOH CAH TOA. So the S stands for sine of the angle theta, O is opposite, and H is hypotenuse. So SOH CAH, that C stands for cos of the angle theta, A is A, H is hypotenuse, and then we've got TOA, T is for tan theta, O is O, and A is A. So we've got SOH CAH TOA, that will get ingrained into your head. Really, it's really nice and easy to say and to remember. SOH CAH TOA is how we remember these trig triangles, okay, which are really important. Right, so let's get into looking at an example of finding a missing side using trigonometry. So the question says, right, use trigonometry to find the length x. And the most important thing, or the first thing that you must always do with these questions, is you label your triangle with regards to the angle. So my angle is here. I've been given the opposite side, which is x here. So let's go and call that one there O for my opposite side. And then my longest side, opposite the right angle, is my hypotenuse. Okay, and the side left over is my adjacent side. Right, but I always tell my students, leave the side unlabeled, so don't label the side where there's no information, otherwise you might get confused on which one to use. So because there's nothing on this side here, don't label it, okay, leave it unlabeled. And then, right, we've got the two sides we've got labeled are O and H. You then look over to your trig formulas, SOH CAH TOA, and you see which one of these has got both O and H in it. So if we look at TOA, well, we've got O, which is good, but we have not got H. We've got tan theta and A, so this is not good. CAH has got H, which is good. I've got H here, but there is no O, so I'm not using this one. But then this one, SOH, I've got O and I've got H, I've got O and I've got H. So this is a triangle that I want to use. Okay, so that's done. I want to find this side here, because I want to find the missing length x, which is this one here. Well, x is my opposite side, so I put my finger over that O. So literally put your finger, if you need to, on the screen, and you can go and say that O is equal to sine, it's not just S, do not just write S, you've got to write sine of the angle. So sine of the angle, theta, and you're timesing it by the hypotenuse. So you're timesing through by H. Okay, so once you've got your formula, it's just a case of substitution now, right? So O is equal to x, so x is what I'm trying to find, which is equal to sine of the angle, and the angle here is 36, and then you put it into brackets, 36, and we're timesing through by h, well h is equal to 7, so times through by 7, okay, and there we go, and we go and type that into our calculator, so sine 36, using those brackets, otherwise it might, if you don't have the brackets, your calculator would do something different. Got to have those in there. And that's going to be equal to 4.1 centimetre to 1 decimal place. Okay, and that's my answer, right? So 4.1 centimetres is the length of that missing side there, which looks about reasonable, right? It's less than the hypotenuse, the longer side, so it seems pretty good. So really, right, there are 3 key steps there. You label your triangle, okay, using your sides, O, H, and A. You then choose your formula, and then you substitute into your formula. Okay, so we'll look at another example, and then you can try one yourself. You can try 3 yourself. We'll look at one more here first. So again, right, step 1, you must label your triangle with regards to your angle. So if you want to, right, you can go and label this side here as O. We will get rid of it at some point, but often the pattern is I go opposite, hypotenuse, and adjacent. So we can see that's opposite there. Your longest side opposite the right angle is your hypotenuse, H. Your leftover side next to both your angles is the adjacent side. But again, right, I always say don't label the side where there's no information. Leave it blank. Otherwise, you might get confused which formula is used. So leave that one blank. Okay, and then, right, I've got A and I've got H. So I go through my formulas again. Well, so this first one here, it's got H, but it has not got A. I need A. A is not in this. CAH has got A and it's got H. Right, so this is the one that I want to be using. I've got A and H. And I'm trying to find the length x, which is my hypotenuse. So I put my finger over hypotenuse, cover it up, and I go and say that h is equal to adjacent a divided by, so a divided by cos of the angle. So a over, and you don't just write c, otherwise it doesn't really make sense. You've got to say that it is cos of the angle theta. And then it's your substitution. Right, h is equal to x, that's what I'm trying to find. And that's equal to a, which is 25, over cos of my angle, so cos of the angle 40. And then put that into your calculator, and that is it. Okay, so 25 over cos 40, which is 32.6 centimeters to 1 decimal place. Okay, and that is my answer. Does look reasonable. Well, x is my hypotenuse, my longest side. I've got 32.6, which is bigger than 25. Yeah, it seems pretty reasonable. So that's good. So we can always kind of make a realistic check. So that is really good. And that is my answer. Brilliant. So what you can do here is you can pause the video. You can give these 3 questions. Here we go. Of finding missing sides in right angle triangles. Fast forward to the end, and you can mark your work. So let's go through it together now. So first one. Right, first step, always label your triangle. We've got an angle here. I use a different colour. Let's go and call our side opposite the opposite side. And this here is my hypotenuse, but there's nothing there, so leave it blank. And then my leftover side is my adjacent next to the 2 angles. Okay, so I've got O and I've got A, which means, going through my triangles, well, the first one, it's got O but not A. Here I've got A but not O. My last one, it's got both O and A. Perfect. I'm using TOA. Okay, TOA. And I'm trying to find this side here, x, which is the opposite side. So if you put your finger over opposite, and you go and say that, well, O is equal to tan of the angle theta times through by adjacent. So tan of the angle theta times it by adjacent. And then you just substitute in your values. So O is equal to x. So x is equal to tan of the angle, which is, I'll put it in brackets, 22, timesing through by the adjacent side, which is 18. And then x is equal to, put it in your calculator, and that's going to be your answer. So tan 22 times 18, which is 7.3 centimeters to 1 decimal place. You can round it how you want to. I'm not too worried, right? But that's our answer. Okay, does that look reasonable? Well, it does, yeah, because you've got a really small angle here. You've got this base here. It seems reasonable. So that is good. And that is my first answer. Second one. Again, let's go label your triangle with regards to the angle. So I've been given the opposite side, opposite the angle. I've also got my longest side here, opposite the right angle, which must be my hypotenuse. This side here is the adjacent, but again, right, there's no information there. Leave it blank. So I've got O and H, which is going to be which trig formula? Well, O and H is in this first one here. So this time, I'm using this first one. And I'm trying to find X, which is my hypotenuse. So you put your finger over that one there, your triangle, and we go and say that H is equal to your opposite side, so O, over sine of the angle theta. So sine of the angle theta. Okay, and again, don't just write S, otherwise it won't really make sense. And then you just substitute in your values to that formula. So H is equal to X. So X is equal to your opposite side, which is 8, over sine of the angle. So sine of 40, and put it into brackets, that part, and then type it into your calculator. So we've got 8 over sine 40, which is 12.4 centimeters to 1 decimal place. Okay, and that's my answer. And again, let's do like a bit of a check here. Does that seem reasonable? Well, yes, it does. Hypotenuse is my longest side, and 12.4 is bigger than 8. It seems okay. Yeah, good. So we can always make a logical check at the end. Okay, last but not least, this one, probably trickier just because the triangle's been rotated and you've got to be a little bit more careful, but let's just go through it in the same way as before. I've got my angle. The side opposite the angle is my opposite side, but it's blank, so leave it blank. my longer side is the hypotenuse, which is always opposite the right angle. So that must be my hypotenuse, h. And then the leftover side is my adjacent side next to my two angles. Okay, so even though the triangle is rotated, it is a right angle triangle. I just apply it in the same way. It's just, being careful with labeling my sides. I then go through and check which formula I need to be using, right? So I've got A and H. Well, the first one, SOH, does not have A, but then CAH is good. I've got A and H, so I'm using this one this time. And I want to find the hypotenuse, because that's my missing side, X. And hypotenuse, put your finger over it, and we can go and say that H is equal to A over cos of the angle theta. So cos of the angle theta. And then you substitute in your values into the formula. So H is equal to X. So X is equal to A, which is 28. So 28 over cos of the angle, well, the angle is 48. So cos of 48. And then put that in your calculator, you get your answer. So 28 over cos 48. And we get 41.8. So 41.8 centimeters, again to one decimal place. Okay, and that there is my answer. And does that seem reasonable? Well, it does, yeah. Hypotenuse, my longest side, 41.8, bigger than 28. That seems reasonable. So good. So hopefully, right, that has made us realise that trigonometry really isn't something to be scared of, right? It's just labelling your triangle and then choosing the formula you want and then substituting your values into your formula. Okay, but we do need to know this SOH CAH TOA off by heart. Okay, but I really like these equation triangles because look, and people might say that you need to understand you're probably right, you need to understand the rearranging part. You do, but I think for the time being, this is just gets us straight into the maths of trigonometry, which is useful. Okay, thank you.